All right. Hello, everyone. How is it going? Just a quick mic check, audio check, video check. You can see me, right? Hi, hi, hi. The music is gone. Okay, I'm gonna play some music when we are live coding. That would be pretty awesome. But thank you so much for joining us today. I see the excitement. Hi, Sohim. Hello, Arnab. The enthusiasm is great. Thank you so much, Akir. Amazing. I'm so excited that you're here to learn Kubernetes. I'm so excited. I want to learn Kubernetes. Like, it's going to be so much fun. How do you pronounce Kubernetes? Good news for you. All three options are correct. You can pronounce it however you like. Kubernetes, Kubernetes, anything that you like. Hi, Kavilla. Hi, everyone. Amazing. Uh, awesome. Wow, the buzz in the chat is amazing. I'm so glad about it. Uh, cool. Awesome. So, a quick introduction about myself. Um, I'm Ashwin Kumar Uppala, a coach at Major League Hacking. My pronouns are he, him. I love participating in hackathons. I love hackathons. And if you have been participating in it, Global Hack Week is a great way to get started. In fact, I got myself started in Local Hack Day. That was like 2020, 2021. And this is where I started, and it was an amazing experience. I'm currently running on Zorin OS, which is a flavor of Ubuntu. So this is my first time like using Linux as my primary PC, and it is pretty impressive. It is a different vibe from using Windows. I've been using Windows like for most of my life. And I started running my shell script a couple of days ago. It was my first shell script to automate a very simple feature. It's pretty interesting. It was pretty fun. And here we are today trying to learn how Kubernetes works. Now, before we jump into that, make sure you have checked in. I want all of you to win those amazing unique stickers. So I'm gonna drop the check-in link right here. Uh, Make sure you have checked in for this event and get those awesome points for your guild and for yourself too. That is right, Joshua says. So check in, everyone. Hi Ashish. Hello. Awesome. Great stuff. Once you have checked in, take your time. You can do it while, or you can do it, just make sure you do it during the event. Uh, we are going to cover quite a lot of basic stuff today. Kubernetes is huge. It's huge. It's like the Olympics. And I'm going to deep dive in one of the sports before we get into another. All right. So first of all, welcome to this technical live stream. Feel free to ask any questions in the chat. I have it up here. I'm loving how you folks know each other. This is really great. Making new friends in chats. How to check guild points? I believe you get them via email. You can ask that in the Global Hack Week catch up that happens every day. Uh, but we will be talking what we are going to build. All right. And before Kubernetes, there's a couple of stuff that you need to know. And I'm going to go through that. I'm going to make sure you know everything that we need to know before we even jump to Kubernetes. Uh, with that said, let's see what we have. Wow, the chat is amazing. Okay. It is so hard to catch up with you folks. Yes, this is a three-part stream. That means today we are going to spend a couple of hours explaining stuff, and it's not going to be complete. I'm going to take up stuff tomorrow at the same time in part two, and the third part will happen on Friday evening. So it's a three-part stream because the subject is quite lengthy, not lengthy, I would say it's quite fun. And I want to make sure that you folks follow along me. So I have resources prepared for you. That is right. Even if you are unable to catch up here, or if you don't feel like following up with me right now, I had created a GitHub repository for you all. I'm just gonna drop that right here. Clone it, star it. You can take a look while I'm sharing about stuff, or you can check it out later. Everything is there, and yeah, I love GitHub too. So we are going to demo it. We are going to create our own application, deploy it on Kubernetes. What is that? Why should we do it? We're going to discuss all of that. But by the end of this three-part stream, you will have your own cluster running. You will have your own project running on Kubernetes. Uh, Hope this three stream gives you confidence on Cube. I will try my best to do so. Don't worry, we got this. We can do this. All right. Um, yes, the resources has a setting up section where you can install stuff if you don't have that already. It's all right if you don't have to. I'm going to show you how it's done anyway. We're going to go through it step by step, and yeah, it's going to be pretty simple. Cool. Kubernetes. However you pronounce it, I pronounce it Kubernetes. Some people pronounce Kubernetes. Everything is fine. It is also known as K8. The reason being the number of letters between the K and the S is 8. So it's called K8. It's pretty simple. But it is an open source system for automatic deployment, scaling, and management of containerized application. That's a lot of jargon right there. Let's go through this one by one. Like, what is that? Okay, it's open source. That means the code is online. It's on GitHub repository. It's free for anyone to use. It is a system, so it has multiple configurations in it. It's not a single tool. It's a system for automatic deployment. What is deployment? When we create our project or whatever you create, when you deploy it, when you produce it to show it out there, like using Netlify or Vercel, or when you produce it to automate it, it's Kubernetes is used. All right. To scale, what is scaling here? So if you want to increase the performance of your infrastructure or the capacity, for example, let's see, we have WhatsApp. So WhatsApp, when in 2017, had a very limited usage, and it blew up in lockdown. Everyone is starting to use WhatsApp. Why did it never slow down? Uh, on the other hand, I have my examination website. So if you have given JEE exams, which is entrance exams for engineering in India, one thing I've observed is that the website slows down or crashes when everyone starts to use it on the result date. But that never happened to WhatsApp. Why is that? Because they were able to scale it. How that scaling works, that's not our concern. The concept of scaling matters. So, can you scale? If your demand of your project is increasing, can you scale it increase? Or if the demand of your product is decreased, how do you scale down to save costs? So that is what scaling comes in. It's used to manage containerized applications. What is containerized applications? We're going to come through that soon. Wow, everyone relates to government website. Okay, awesome. Feel free to ask any questions throughout the stream. I'll love to help you out in that. Now, take this example. A typical system that we have consists of hardware, my CPU, my GPU in this laptop. Then there is the operating system. I have Linux right now, and on that the application is running. I have Chromium browser running, Brave browser running, where the stream is happening. I have VS Code running, Spotify, all everything else, right? This is a typical system. Now, there was a time when virtual machines were pretty popular. So, virtual machines is running another machine which is virtual over top of your current system. So, if you don't know about it, you can, if you're on Windows right now, you can run a virtual machine which has Ubuntu inside of it. So, it will be like a window, and you can run. It is like literal Ubuntu is working inside your Windows. Similarly, I'm on Linux and I can install tools for virtual machine which runs Windows on my Linux, and which is totally possible, which is great. So if I create an application in my Linux right now, which is, let's say, is a Python script, and Joshua here is watching it through Ubuntu through VM, and I want to share my Python script to Joshua, but my version of Ubuntu is different from Joshua's OS. So one way to do that is, one, Joshua has to run the VM, which is exactly of my OS. So I'm running Python on my Ubuntu and Joshua is on Windows. So he has to first run Ubuntu virtual machine, and then he runs that Python script to give the exact same experience which I had. Now, the problem with that is it takes a lot of resources. To run a simple application that is a Python script, it is taking the equivalent resources of CPU, RAM, and memory, which can run a proper separate operating system. So just to run a single small script, I have to run a whole new operating system inside my operating system. That is very resource intensive, right? Hi, you're not late at all. We're just discussing what is a virtual machine right now. So before we jump into Kubernetes, I want to get over with quick nitpicks that you need to know. What is virtual machine? What is containerization? So virtual machine, in simple sense, is basically running a machine on top of your original operating system. So I have Linux here. Uh, on top of that, if I run a virtual machine, I can run another Linux or another Windows or anything that I like. Why should I do that? People do that so there is consistency when you're trying out your product. uh, Let me give you an example. So let's pick two folks from the chat here. Okay, we have Ashish here. I'm going to pick Ashish and Pratik here. All right, so this person is Ashish. Okay, this is my not plushie, this is Ashish, and this is Pratik. All right, so Ashish and Pratik. So Ashish makes something, let's say a Python application. All right, Ashish made something in Python, but Ashish is on Windows right now, and Pratik is on Linux right now. All right, now let's take a simpler example. Let's not take an application. Let's take something real life, which we all like, coffee. All right, so Ashish is holding a coffee. You can see it right here. It's a very cute coffee mug. So Ashish is expert at making coffee. All right, and Pratik got to know that, and Pratik wants to try that coffee out. Now, there are a couple of ways Pratik can try out the coffee the way Ashish makes. The first one is Ashish gives the cup of coffee directly to Pratik. That means they have to go all the way to Pratik's home and give that coffee that Ashish made. That is fine. That is equivalent of taking my PC and coming to your place to show you my application. Another way is Ashish, let's say, takes a sticky note, writes down all the ingredients, and gives that to Pratik. All right. Now, that is fine. That is what exactly virtual machine we are trying to achieve. So, uh, this is the instructions for virtual machine. Pratik leads it. Pratik says, okay, Ashish used Ubuntu and made some things, and they're gonna follow that. All right. But there is a problem. They soon realized that the coffee tastes different. It's not exactly like what Ashish made it. And why? Well, if Ashish said 3 spoons of sugar, the size of spoon was different what Pratik had. The type of coffee Pratik used was different. The container, the cup that Pratik used was different from Ashish. The instructions were exactly the same, but just because the host was different, the experience was different, and that made Pratik very sad. So Pratik asked Ashish, hey, what's another way? Tell me a better way. Okay, your instructions are fine, but it's not working on certain cases. How do I make it better? Ashish, being known what containerization is, takes a container, a box. All right, it's just simply a container. I just took a simple container and wrote a container in it. I don't know if you can see it straight. Okay, it's not mirrored. Amazing. So Ashish Takes a container, puts exactly the stuff which Ashish had at home. So I'm just putting random stuff in this, all right? And the ingredients of Ashish coffee, all right? The exact amount what Ashish made themselves, and give it to Pratik. Now, Pratik took the container. Notice here the transportation happened in the container. Whatever is inside the container has not changed at all. So no matter what size of spoon Pratik has at home or the size of the cup Pratik has, when he mixes all those, when he takes the stuff out of the container, it's going to be exact same experience as Ashish had. That is what containerization is. You are basically bundling all that software in a single container. You're just shipping it, and whatever is inside that container does not change. Uh, the advantage of using a container is that I don't have to rely on a separate operating system anymore. I don't need to set up a kitchen, which is like Ashish, to make something, the coffee that Ashish makes. I only need that container which has the ingredients and the instructions. That is what containerization is. So, container models are smaller in size, much smaller. They're fast, they're lightweight, and they only have the things that are required. Uh, Hi, Akil. What did you miss? We are discussing about containerization before we get into Kubernetes. Quick recap, quick prerequisites of things you need to know. Containerization is very simple. You basically enclose all of your application in a single container, telling that these are the things that we require, and that container you give it to your friends, which they can use. Think of it like a GitHub repository. So all your code is in the GitHub repository. All my code, which I just explained, which I tagged here, is in the GitHub repository. uh, Whatever code it is in there, it will be same for all of you. So think of it like that, but it's a little more abstract than that. Now, so we have the OS layer in the virtual machine, and then we have the app. But because I'm shipping a container right after the kernel, which is the one that interacts with the host OS, I can directly use the application. So my container only needs to pull the stuff that is required for the application, and it removes the need of a separate OS entirely. That is the advantage of a container. Never forget, always remember while drinking coffee. Yes, coffee is great. Awesome. So, pretty simple containerization. You are, instead of using an operating system, you are shipping your code in a container. You are telling your friend that, hey, I have built something which is in a different OS, but you're on a different OS. But since I'm shipping you the container, you should not have a problem in using that. Uh, so, how does containerization exactly work? So, this is your program file. You build it into a container, so-called image. An image is just a snapshot, all right? It's like a copy of your file. Oh, you're not late. That's fine. Harsh, that's totally fine. You're not late. We are talking about containerization. Uh, Pretty simple. How do you containerize your application? Uh, the word itself says container, you know. So whatever you put inside a container stays like that. Think of it like, how do you compress your files? You make a zip of your project and you email it to your friend, and the zip is intact. Everything inside the zip is exactly the same. Same goes for container, but it is not dependent on OS. It can work everywhere. Yep, you did not miss anything at all. Now, uh, you build something on your container, you containerize your application into layers, into so-called images, which is basically a snapshot of your container, of your application. That snapshot is recognized by Docker. uh, I was wondering if I could see a practical example. Absolutely, I'm going to show you how to containerize. Feel free to follow up with me if you want to. All right, we will do that. Don't worry. But you know what? Okay, let's do this. We are right on the slide, so let's go ahead. I'm going to do this. Let's go ahead and Container is an application right here. I'm gonna create a new folder, call it GSW. Oops, let's call it GSW December. Alrighty. All right, I'm gonna open a new terminal. There's my terminal. So let me just build a super simple web application. Let's build a website. All right, simple index.html website. Make sense? Let me know if the text is big enough for you. Should be. Let me just be a nice person and hide myself. Nice. That is Zorin OS. That is correct. It's a flavor of Ubuntu. Uh, it literally works like Ubuntu. Oh no, Matt, the stream crashed for you. Let me know what did you miss. I'll be happy to catch it up for you. I'm just creating a very simple index.html. I'm going to containerize this thing. All right. So hello global hack week. All right. So let me just make it an H1 tag in this. Alrighty. Very simple. Let's see if I can open this. Oh, that should not happen. Yeah, pretty simple. I just joined recap if possible for sure. Draven. I'm. I was talking about containerization. So containerization is something you need to know before we get into Kubernetes. It is basically like the word says, you containerize your application, you put it in a container, a very unique container called Docker container. We are using Docker technology. The advantage of containerization, I'm going to talk soon, but that one simple thing is that you don't need to use a virtual machine like running another OS in top of your OS. If you are using Mac and I'm on Linux, I create something which may not work on you. So in order to make sure whatever we are creating is independent of operating system, we need to containerize it. So I'm containerizing a very simple index.html file. I'm gonna do that. Yeah. So uh, in order to containerize this, I need to make sure this website is being served. All right. Now you don't need to have any knowledge of anything that I'm about to type here, because the purpose of this stream is containerization and not web technology or front end and back end technology. But I'm going to create it right here just to give a clear dish. So I'm going to serve this website like, I want to serve it on my local host. I'm going to create an app.js and I'm going to use something called express.js. So let me just zoom in. That's good. So I'm going to use express.js to make sure that my content is served on localhost. All right. It's going above my head. All right, no problem. So simple terms, I am going to create a website and just run it on a server right now. Let's focus on that. I'm simply creating a website and serve it on a localhost website. Uh, yep. Okay, we don't have any questions. Awesome. Okay, so I'm going to use Express framework, which requires me to use Express. So if you have opened my GitHub repository, if you missed it out, let me just put it in the chat again. All the resources that I'm about to use are in this GitHub repository. So I have Git installed. Make sure you have Node installed if you want to follow along with me. So I have Node installed. I have Docker desktop installed. You can install it if you like, creating a Docker hub, or you can do none of that and just watch my stream. Works absolutely fine. All right. Wait, let me just highlight this. Yep. So I have Node installed and I'm using Node.js. Express is a very lightweight framework of Node. So let me just go ahead and initialize a package here. So npm emit, npm stands for node package manager, which means I'm about to start some packages in here. You don't have to know what I'm doing right here. I'm basically telling, hey, I'm about to use some packages to serve my index.html, and I want to keep a note of that. So here it's going to keep a note. Can you give me a roadmap on what there is to learn before and after Docker, so we know what stands after the stream? That we are actually going to learn how to deploy our stuff on Kubernetes, and Docker is the prerequisite. There is a good live stream will happen probably tomorrow by Corona on Linux if you're interested. uh, it's pretty cool, but technically you don't need anything right now. If you understand how basic web works, like how to create a website, or if you have your existing website, at the end of this workshop you can deploy, you can try to containerize your old websites, your old react websites, or anything like that. So right now, just make sure you have understand of HTML, how it works, and basic Linux commands. So I'm feel free to ask if you don't understand the Linux commands. Share the GitHub link for sure. Actually, let me also share it on Discord if you may. Let's see. Uh, we have GHW. We have lots of channels here. Which one should I post it in? Let's put it in. Yep, right here in Ask GHW December. There you go. Command to get package.json is npm init, npm init. It starts package.json, which will keep track of all the packages that we'll use. We'll use one or two packages, but this is, yeah, we are going to use one or two packages. One of them is Express. So, moving next, I'm going to tell it, hey, install Express. Or install for easy. So, npm is like pip, if you know. npm is also like my play store, so it tells that, hey, node, uh, look for a package called express and install it. So what it's gonna do, if I press enter, it's going to this place. Oops. So if I go to npm, it will go to this website, and if I go to express, it's actually going to download this package. So you can see, to install it, the command line is npm install express. A lot of people use it. What is it used for? How do you use it? A boilerplate, and why is it used, and stuff like that. Oh, you have made a website already? Yes. So once I tell you how to containerize your existing website, you can definitely containerize it. In order to containerize, it needs to have some backend. So that's what I'm doing right now. I'm setting up a backend to serve my website. So I'm going to use another package called path. So npm install path. This tells where my index.html is, and then host is on wherever I want. So I will, so this is my express. I'm going to save it in a variable called express. I can put it the same name. Whoops. Yep. I'm going to require path, and I'm going to save that in another variable called path. All right. Now, I'm going to initiate my Express framework by saving it in an app, a variable called app. And also, I want to make sure that my application, once it's running, is hosted on some localhost port. So I'm going to access my process, env.port. By default, I'm going to put it on port 8080. I want to save it in a variable called port, right? Awesome, no questions so far. Now, all right, now my application, I'm going to get it. So it's in my root directory right now. and I'm going to initiate a function which is called request and response. This is a very standard Express format, which if you just go here, you can see this is how you use it. So I'm using that. So here I'm going to give a response which is going to send my file. You can see my VS Code is automatically telling me suggestions and explaining me what's happening here. So transfers a file with this path. So yes, I want to transfer a file uh, whose path is, so I'm going to join some words. That is my directory name. And my file name is called inside the path index.html. It's all right if you don't understand anything what's happening around here. Pretty simply, I'm sending a file which is right here, index.html, uh, to my application, which will host it on Express and export it to port 8080. After exposing it, I have to listen to it. So I will tell that listen to the port that I told you to. And for my sake, I'm going to log basically output in the terminal that server has started on http:// localhost that port that I told it to. Easy peasy. To use Kubernetes, do we have to learn backend? No, but I would recommend it's a plus if you understand how backend works a little bit. Express is a great way to start. Resources are there again in my GitHub repository. So if I go here to my GitHub, at the bottom, I have put some resources for you to learn after this workshop. You can do that. But remember that containerization is working because there is a server. So you are going to host your website and Kubernetes. For that, Kubernetes is the backend. So it's the platform which manages the containers for you. So it has very deep dives with backend web technology. So it's a plus if you know. It's all right if you don't. We're going to go through it. Uh, Thank you so for letting me know. If you are following me, I'll go pretty slowly. Once again, the code is in my GitHub repository. Let me just add some comments if you wanna understand. So index file goes here. Again, the agenda of this workshop is not to learn backend, but how to containerize this application. So I'm assuming you already have a website like this or a React application or any other application which works like this. Do we also add data CSS file? No need. I'm not using CSS. It's simply a plain HTML file for you. What keyboard I'm using? It's Cosmic Byte Mechanical Blue Switch, and yes, I love it has a nice click to it. Awesome. So let's see if this works. I'm going to open my terminal and I'm going to tell Node to run app.js. Drum rolls. Server has started. I'm going to control click on this, or I'm just going to copy this for now. On a new URL. Yes, it works. Can you explain if we have to use it? How can we do? Okay, if you want to use CSS, use CSS like any other. How do you use CSS? You use CSS, you link it to your index file, and it will work just fine. But for now, let's just stick that we have a website, and it is being hosted on a server which is running on Node on this local host. Pretty straightforward, pretty simple. Uh, if I do a control C here, oops, you can't see me. So it's running on this server. I do a control C, and if I try to refresh it, whoops, we are gone. We lost it. It's not working. Okay, so I will come back to that once we have containerized, but thanks for letting me know. Let's see if, okay, we'll work on CSS too. We'll work on that too. But I would highly focus on containerizing right now. Let's focus on how can I get what I just made right here to all you without you, installing anything else. So now here's the problem. If I want to share you this simple index application, um, I have to tell you that you have to install Node.js, you have to install Express, and then whatever packages that we need, path, and then you need to have a browser and stuff, and then you can use my application, right? Even if I push this in GitHub, you still have to install Node, you have to install Express and path, and then when you run node index, sorry, app.js, then it will work. Otherwise, it will not work. We want to avoid that because the way to install Node in your PC is different than mine. I'm using Linux. So for me, it's a command. For if you're on Windows, you have to install an installer. If you're on Mac, you have a different command. And it's so annoying, and at the same time, it's risky. What if the version of Node that you have is different from mine? I have 18.12. And what if you're on 17? It will work just fine, but it can create problems in the future. And that is why we want to make sure that to have the same experience, we will containerize this whole application and then ship it. It's showing dir name not found. Make sure you are using index.html or whatever the file, wait, whatever file that you have. So I have index.html right here. So I'm using that with a slash here. It looks for directory called index. Inside the directory, it looks for something called index.html. All right. Or if you want to, if you don't want to, you can simply go here and just clone my repository. I think I already, yes, I already did this hard work for you folks right here. All right, it's double underscore. Yes, thanks for pointing that out, Akshat. It's double underscore right here. Okay, so this is the application I made. Now I want to containerize it. Uh, if you have Docker Desktop installed, run it. It should look something like this. So I'm going to run Docker Desktop. It looks something like this when I open Docker Desktop. Docker Desktop is GUI for Docker. So Docker is a tool which helps us in containerizing application. It's a very, very popular tool. Uh, Again, I have given how to install Docker Desktop in here. Just press the button, and there's also very nice documentation on how to get started, but that's all right. I personally don't prefer Docker Desktop because it's very resource intensive, but it has everything that we need for this workshop, so it will work fine. Docker Engine is absolutely fine. If you're curious, what is Docker Engine? So this is Docker Engine. Basically, Docker runs with inside your system, so you don't see it like Docker Desktop. It runs alongside. If I show you this slide, let me go back like this. So on the right hand side is how a Docker system works, unlike a virtual machine on the left. So on Docker, I can run my apps on the right hand side. So yeah, we are right here right now. Now back here, if you want to install Docker Engine, you can install it manually for sure. Follow these steps for Windows, Linux, and stuff like that. Totally fine, totally fine. But if you're new here, Docker Desktop is great. It gives you everything visually, and we will use command lines tool too, but we'll use Docker Desktop to rely and see and verify anything. Can anyone simplify the process to install Docker on Windows? Yes, we can. Just go to Docker Desktop. Let me just copy this link for you. And so if I'm on Windows, I would go and click on Windows right here, and it should give me an exe file to download, and I'll just click next and give all the permissions, and Docker is installed on my system. You do need to set up WSL or Windows Subsystem for Linux. I guess there's a very nice documentation on how to do that. Is Linux mandatory for DevOps and KH? No, not really, not at all. You can run Linux in your Windows too. with WSL. But Docker Desktop is available in all platforms, so it should not be a problem at all. Uh, how do I check Docker is running? Well, if I just hover here, oops, you can't see my, wait, how do I, okay, I'm just gonna hide myself. So on the bottom right, if I just hover, it says engine is running. That is one way to check it. Another way is just open a command line terminal. Oops, I'm just gonna make it big, and I'm gonna run Docker PS, which stands for process. So show all the processes that is Docker running, and it shows nothing is running, but Docker is running right here. You can see. If I just close my Docker, it's going to give me an error. Is this resource hungry? It varies. I mean, not that much. In fact, let me check right now. Yeah, it's pretty good. I have a lot of stuff open. It works just fine. That's totally fine. If you're using Potato laptop, I would recommend using a Docker engine. But if Docker desktop works fine, that is a-okay. Docker is running in my system. All right, it says something called container ID, something called image, command, created, status, what. I don't know. It's all right. Image is what we want to create here, right? In fact, if I go here and go to images, you can see I have a lot of old images. You might see nothing. If I use command called docker images, you can see it hints me that it will list all the images that I have, and I have a lot of images from months ago. But that's all right. But we want to create an image of this app that we just created. All right. How do we do that? So, in order to tell Docker, think of think of it like how I proceeded in creating this application. I initiated my packages. I ran a command called node app.js and a couple of more commands to run my application. Docker will do exactly that. So in order to containerize, you need to create something called a Docker file. So I'm going to create with a uppercase D or Docker file. D has to be uppercase in order to Docker to detect it. So create a Docker file. We're going to create a Docker file, and I'm going to tell Docker that use an image. We are using Node. So we are going to use Node, and we can do latest. Yeah, let's do the latest version of Node. So I am probably on Node version. Hit this, and this is the latest version, and I'm going to tell Docker to use the latest version. Now, here's the beauty of Docker. Before I containerize my own, I can use all the containers that other people make in the world, just like GitHub. You can use anyone's repository. You have access to it. You can clone it. I can use other people's container. Let me show you how. So Docker run Ubuntu. All right. So wait, before I do that, echo, sorry, cat /etc/os release. Check out the details of my system. I am on Zorin OS, all right, version 16.2. All right, and now I'm going to run Ubuntu inside it, but without running a virtual machine. Now, a normal user will be using a VM. You install a virtual machine. There are a lot of if I do virtual machine tools, there are a lot of tools that I can use for virtual machines out there. There's Parallel Desktop, VMware, but I want to run a virtual machine and I'm going to run it on Docker. So check this out. Docker run. I'm going to say Ubuntu. What is it going to do? I'm going to run it. It says unable to find locally. So it's going to look online and it's downloading some stuff. Friendly reminder to have water, and I'm running Ubuntu right now, but I can't see it. Let's check it out. Docker processes. All right, Docker. So what just happened is I ran Ubuntu and I closed it immediately. So I'm going to say Docker run interactive environment Ubuntu. Now, if I do the same command that I did earlier, I'm running Ubuntu 22. What is happening here? My this terminal is running Ubuntu, and if I open a new terminal and I'm running Zoe OS here, and this is not even a virtual machine. I can do anything that Ubuntu does. So what I just did is I went to Docker Hub. It went to Docker Hub. Let's wait for it to load. It went and it looked for Ubuntu and it downloaded this Ubuntu image and it's running it on my command line interface. I have not installed anything. I have not required any prerequisites, anything. Only thing is Docker and it's running Ubuntu in my shell. Let's exit it. Docker, oops, run interactive environment node. So I don't have a node locally here, image. It's gonna pull it from the website. So if I search here node, I have node here and it's gonna pull my image and I'm going to run Node.js on my system without installing anything else. I'm gonna wait for it to download. I know, right? This is great. Why am I not able to link Docker Hub with Docker Desktop? So if you go here on the top right, you should be able to see the option to sign in. If you click on sign in, it should open Docker Hub and you have to authenticate from there. And then you should be able to log in. Okay, this is taking a lot of time. Let's see how big node is. Oh, we are almost done. Nice. Node version. Oops. Oops. But we are running Node as far as I'm sure. This should work. Let's see. Yeah, we are using Node. The Node.js that I just wrote in my program, I had to separately install Node by going to the Node.js website and then configuring it, and then I'm able to use Node. But because of Docker, I can use everything in my command terminal, and nothing is installed right now. So start exit if I believe. Yes, that is right. Now, if I go to Docker process, nothing is running. But if I go to Docker images, apart from these, if I go to the top, I have Node and Ubuntu here. Pretty big size, but I don't have to download them again if I want to run them. Let me just show you in Docker desktop. If I go here in the images, oops. Oh boy. Yeah, there you go. I see Node. Oops. Are we back again? Yeah. Sorry, my system almost crashed because I opened Docker twice. Yes. Share screen. We are back. And we are back, boys. We are back, everybody. Awesome. So I have Docker. Okay, because I have two containers running and it's taking a big toll. So what I'm going to do is I'm going to tell it to delete it. So yeah, I don't need this. Oops, first I have to delete the container. So I'm going to delete the containers, and then I'm going to delete the images because I'm not going to use them again probably. I can use, so Docker Desktop is a great way because I can do all that graphically, and I can also do it via the command line. Highly recommended that you use command line if you're using it for the first time, like Docker images, taking out the images, and if you want to delete an image, wait, let me just full screen this, is I copy the ID of my image. So you can see the image ID on the right, and it's Docker RMI, which is remove images. It says right here, and followed by the ID. So highly recommend you try it terminal for once or twice, but it's always okay if you are using Docker Desktop. It's all graphical here. That's the beauty of Docker Desktop. So Docker, that I can use anything which is there on the Docker Hub and use it locally. Now I'm going to do the reverse. I'm going to turn my project into a Docker image, which we just used. And then I'm going to push it to Docker Hub. So all of you can use it. Docker is that heavy? No, it's the Docker desktop and the two containers that were running back to back. That's why. You can limit the amount of memory Docker takes. So I can go here and go to resources and control how much CPU memory and swap memory and stuff that Docker takes for me. I have set it to 4. You can set it less. So it's easy on your system. Cool. Back to my Docker file because I'm about to create a Docker image. I'm going to add a label. It's not mandatory, but a good idea to add label. So you can see it's a key value pair. I'll say I am the maintainer, and I'm going to add my name. Let's say Ashwini XE. Now, remember Docker is a container. Can you see my? Yeah, you can see me. So Docker is a container, all right. I have to tell what do I want to put in this container. So I am coming and I'm going to say copy everything in my folder to the source folder of Docker. You can see on the top it says name of the destination or folder, copy new files and directories to the image file system. So it is same as what I have, what Ashish had in their kitchen to the source, to the container. So Ashish want everything that was in their kitchen, which helped them make coffee, to the source file. So that's what this line means. Copy everything, that is the dot, to the source of my Docker system. Next, I'm going to run a command, change directory to my source folder. CD means you can change the directories, basically same as going into a folder. So I'm going to run a command telling it that make sure you are in the source folder, all right? And then I'm going to run npm install. What does npm install does? So inside the Docker, it will have all of these files, all right? And the package.json has these dependencies. These are the files that are required to run. Whether it is inside your Docker or not, these files are required to run my image. And it's going to run this command inside the Docker container. So inside the container, it's going to make sure it has these dependencies. Even though my system does not have that, the container should have these things. So that's what it means by npm install. So it's going to install all the dependencies that are missing from my folder. And that actually goes in the node modules here. So you don't need to know what's inside node modules, but these are the modules which are required to run my file. After that, I've installed stuff. I'm going to expose my 8080 port inside the Docker container, basically making a hole and telling that this is the port you're going to serve my websites from. And then I'm going to run a command. can be cmd or run. Again, I'm going to make sure I'm in my source folder of my container. And remember, we ran app.js. So remember that we ran node app.js in the final command to make sure our website is running. And this is the website. So I'm going to tell Docker to do the same thing. So this is my recipe inside the Docker container. And Docker is going to make sure that it has that exact same steps that I ran. So the other person who has the Docker image runs it properly. Make sense? Awesome. Let's go ahead and open a terminal. Let's open an inbuilt terminal here. And I'm going to build my image now. So I'm going to say Docker build. So I'm going to set -t, and T here means why use 2 times run and command. I mean, you can use it in one go. I want to make sure that I have my packages installed before I run the application. Let me show you what I mean by that. So let me delete the node modules here. Let me just delete this folder, which has all the modules gone. All right. And now let me run this. Oops. Node app.js. There's an error. What does it say? It says, if I go on the top, it says it's throwing an error. Cannot find the module called express. So I used express here, but it does not know what is express. And I used a couple of more stuff. I also used path, and it does not know because there is no module here. How I'm going to install those modules? npm install express, and then npm install path, and then if I have 5 more modules, I have to do npm install all of that. Instead of that, I have a single file which tells everything that I need, called the package.json. It's automatically created when you run npm init in it. So all I have to do is tell npm install. That's it. It's going to install all the dependencies that I have here. See? And node modules is back. If I do npm list, I have express and path installed again. So that's why in the Docker, I have to run npm installed for sure. I can also put run here. This should work just fine. But npm install first, then I'm going to expose my port where the application should work. And then once it is open, let's start the application. This is a precaution just to make sure we're in the source directory where all the files are. All right. Let's go ahead and build Docker build -t, which stands for tar. But that's fine. Tar is basically a compression. We are compressing it in a certain image. My username. So make sure you have a Docker Hub account. That's a plus. This is my Docker username, followed by / my repository name or whatever I'm using, my file name. Let's call it GHW. All right. Colon version number. So this is my first version. I'm going to call it 1.0. This is very important. You need to put colon and 1.0. But what are the files that I'm going to add? I want to add everything in this folder. So I'm going to remove node modules. I don't think we need that. That can be installed later, but everything, that is what dot is. Let's go ahead and hit enter. Let's see if this works. Going well so far. Couple of stuff is happening here. There's a lot of SHA 256 weird cryptic words. What are these? These are layers. These are image layers. Each command that I just wrote is a separate layer. Why? This is what the difference is between a virtual machine and a container. The advantage of layer is that it can be shared across different processes. Think of it like sugar. So if you have a source of sugar, you can use it everywhere that you want, compared to a sugar sachet that you have to have individual of them. Uh, so let's wait for this thing to happen, and a quick reminder for water break. Stay hydrated, y'all. While this is building, let's see what we're going to do next. Oh no, my slides are down. Is my slide back? Let's hope it is back. Yes, my slides are back. So we are right now here. We're building a container image. Still going. Oh, okay. Server has started. Okay, I think it's running right now. Oh, it's almost done. 8 by 9. Nice. So next step will be to host it in a registry. Let me see. It says server has started on localhost 8080. I'm going to open my browser. Localhost 8080. No, it does not work. Oh, it's still building. So let me check the image built here. Refresh Docker images. Okay, I don't have my image built yet. Let's build it again. Before that, let me just do an npm install. Let's just, for precaution's sake, let me build this again. Oh, okay, makes sense. It needs to be CMD because we want it to run not right now, not while building, after it has built, after it has been built, and that's why we want it to be CMD. Makes sense. Now let's do it again. Now it should stop. There you go. If I go here to my Docker desktop, voila, I see something called ashwini.exe/gsw. Oops, I opened it. Even in terminal, if I do Docker images and scroll to the top, I see ashwini.exe/gsw 14 seconds ago, version number 1, image ID, and stuff like that. Quite big. What's the use of this? Now, this is image like any other image that I showed you, like Ubuntu image and Node.js image. I want to run this now. Now, instead of running node app.js, I want to run this image. This image has everything that I just made. HTML file, app.js file. It has everything that I just made. So I'm going to run this. I'm going to say docker run. What's the file name? ashwini.exe/gsw, latest version. But if I run this like this, okay, let's run this. Server has started on localhost 8080. So localhost 8080, I'm refreshing, it's still not working. What's happening wrong here? What's happening here is my application is putting an output to 8080, but my Docker has not opened its port. So inside the application, it is open, but not in Docker. So I'm going to tell my Docker. So I'm going to stop this. Let's see if I can. Yeah, you can see it is in use. I can tell it to stop. Gonna wait a couple of seconds. I'm going to tell Docker to expose a port. So it has stopped. So I'm going to tell Docker run -p. It says publish all export ports. 8080, 8080. Inside my Docker, my app.js is exposing it to 8080, and I want outside the Docker to be 8082. So that's why I'm using 8080 colon 8080. You can use anything that you like. Inside it has to be 8080 because I'm using 8080 by default. If you change it inside, you can change it your way too. So followed by my image name, ashwini.xe/gsw latest version. If I hit enter, the server has started. Let's have some drum rolls. And it works. And this is working on Docker. This is running on Docker. If I open Docker here, right here, you can see there is a container that is running. Port is 8080 and it started 20 seconds ago. If I click on this link, it will again open this right here. Now the beauty of this is I don't need any of these files anymore. I can delete this whole folder. I don't need any files and this will work just fine. So let me just go ahead and stop this container. Oops. Now I want all of you to try my image. I made something cool and I'm like, hey, wow, V is in the chat. So I'll say, hey, V, you have Docker? I want to show you something cool that I made in Node.js. They may not have Node.js. They may not have Express installed, but I want them to try this out. All they need is Docker. So I'm going to push my Docker, push my this thing, my image into the Docker Hub. Let me open Docker Hub here. Docker Hub. Let me see what what I have already. So, oops, what did I open? Think of Docker Hub like GitHub. You push, you pull. If you know GitHub, it's very easy to understand. So these are the repositories that I already have, portfolio and pretty old stuff. I'm going to tell Docker to push this image, which is in my system, to the Docker Hub. It's preparing for it and it start pushing in layers again. What are these layers? We're going to check out right now in a couple of minutes. I'm going to wait for this thing to push. So right now we are at this point. The next thing after this is to run in production. That is used by enterprises. So they'll run it in production. But in this case, you're going to use this. You're going to use my Docker image. All right, pushed. I'm going to refresh this. Drum rolls. That's not a loud drum roll, but there you go. ashwini.xe/gsw is on Docker Hub right now. If I go here and copy this command, if you have Docker open right now, go ahead and use this command. You're going to pull my image, which I just created right now. Now, let's see what were those layers, those cryptic words right there. So you see, if I go here and if I go here, it says something called image layers. Oh, you can't see it. I am higher. Sorry. Yeah, I'm going to hide myself. So right here, it says image layers in Docker Hub. If I hover over it, it says click individual layers to view their instructions. All the layers right here are individual independent instructions telling Docker to do whatever we want. So if I click, you can see there are multiple layers, and these layers are what I wrote in my Docker file. Most of that. Copy, source. We have expose 8080. We have copy file. We have CMD node, and a couple of more stuff which Docker adds while building it. So these are the layers which were being copied and pushed. When you pull it from your side, in fact, let me show you, let me pull it right now in front of you. So I'm going to go to image, I'm going to go to Global Hack Week. I'm going to delete this. I just deleted my image, all right? And let me also go ahead. This is fine. And In fact, let me go ahead and delete this whole project. I don't have this project anymore. It's all gone. All gone. I just deleted my whole project which I just made right now. Now, I'm like right you at sitting at home. I don't have my project, but it is there on Docker Hub. So I'm going to make sure Docker is running. Yes, it is running. And I'm going to say Docker run. First, I'm going to pull my image. Docker pull ashwin.exe / gsw latest version. This is the exact command written in here. So, oops. Yeah, right there. So, before that, let me show you. I don't have Docker image. Docker images, I don't have the GSW image right here. So it's gone. It's not on my PC. All right. It's not here. So let me go ahead. Docker pull ashwin.exe / gsw version 1.0. Oh, I just forgot to enlarge it. It's going to check first my local system. It's not there, and it's going to start pulling it. It's pulling all the layers which we just showed. Docker images. Here you go. In fact, it's also here, right there. I used a command to pull it. You can use Docker Hub to pull it too. So you can go to remote repositories, and I can add a repository here too. Awesome. So I have that image now, but I don't have any files. All right, everything is in the image that I just showed. I'm going to run the exact same command. Docker run expose a port called 8080 on the outside and 8080 on the inside of Docker container. And the image name is ashwin.exe / gsw version 1.0. Remember, I don't have the files anymore. I just have the image, that single image. All right. I'm going to run it. Let's go here, open localhost 8080, and there you go. It's running on right. It does not matter I'm on Linux, on Windows, on Mac. It will work because it is independent of any of that. It's running on Docker. It's not running on my virtual machine or on my system. I did not install Node. I did not require Node or any of that for this thing to work. I'm going to use Docker desktop, and I'm going to tell it to stop now. Awesome. We learned how to containerize our application. Maybe you want to containerize your React application, your old web application, feel free to do that. It's pretty fun to share your containers with your friends using Docker Hub. But what is the point of all this? You see, when we're using Kubernetes or something of very large scale, think of it like Instagram or Twitch if you're watching it right now. Twitch, it works on all platforms. And if I want to make changes to Twitch, the last thing I want is to independently make changes to any platform. If I am on browser, if I am on Android app or iOS app, I want to make sure that it is independent, it's working independently of operating system. So all I have to do is make one change and it should change everywhere else. That's the advantage of containerization. The container that I just shared you, if I make changes to that one container, no matter what OS you're using, it will change for you too once you pull it. Compared to that, if I share you my Node application, for example, right here, okay, I deleted my Node application, but I do have this thing. So let's see. So if you pull so this is the Node application that I just made, right? If anything changes in the version here, let's say this single version is 1.4.119 in the future. I don't have 4.19. You may have 4.19. Someone else may not have 4.19. And that is going to create issues because then you have to independently update your application every time, depending on what OS you are on, depending on uh, your OS and your system. But containerization eliminates all of that. Everything, it just works unique because it's a single container compatible with all the systems. The only headache you have to go through is installing Docker, and then every container just works regularly. You don't need to have anything installed. Uh, Kubernetes Kubernetes manages those containers. So what I just made was a single container right here. So I still have it running right here. Yeah, it's a single container. I can stop it, I can start it, that is fine. But a big infrastructure like Twitch has thousands of content, tens of thousands of containers running. A container in India, like in your system, to run Twitch in your phone, couple of containers in North America, where Way is joining us from, couple of containers in the other countries. So many containers to run so many instances. How will you manage all that? You cannot. If a container goes down, who will restart it? So I can restart it here manually. I can run it here manually. That is one container. But when it's thousands of containers, it's very difficult for companies to use it. And here's where Google comes in. Google was running internal orchestration tool to manage all these containers for Google. They call it Borg, B-O-R-G, Borg. And the people at Google thought, uh, this is a very amazing tool, and let's donate it, let's make it open source so everyone can use it. And they renamed it to Kubernetes and donated it to the CNCF, or make it open source. So Kubernetes controls all the containers for you, and this is very handy when you are scaling. Exactly what it said on the first slide, scaling, and when you are managing containers, or when you want to orchestrate or you want to automate your deployments. Let's think of a simple example. FIFA is going on. I'm not up to date who is winning right now, but this is the ground, and all the players on the field are the containers right here. All right. Now, the on the field, without any support, those are all just spread out for no reason. It is the duty of the coach to make sure that they are arranged in a certain way, right? What if one of the player gets injured and he has to drop off? That happens. In that case, it is again the duty of the coach to bring out a substitute player. Or if that's not possible, rearrange the arrangement of the field of the players so we still have the advantage. On their own, the team cannot do that. There has to be a coach which does that. That is exactly what Kubernetes is. It manages all the containers for you. Uh, what kind of containers, if you may ask? That is where microservices comes in. In simple sense, there are two types of services. There's monolithic service, microservices. We just talked about monolithic services. Uh, the websites that we see, the government websites, or why websites crash on results day, when there's a lot of traffic in it, because there is no one to manage the traffic. Um, Plus, a monolithic service is where the front end, back end, database, everything is in a single package. So if one of them goes down, the whole system goes down. That's why you might have seen a couple of websites which say we will be upgrading our services, so it's going to be offline from 12 a.m. to 1 a.m. and they give a timing where the service is not available, because they have to take down the whole service down. Microservices, on the other hand, are each service has their own roles. So front end is different, separate, back end is separate, storage, the database is separate. All of them are connected via APIs. It looks something like this, like how this football field is. It's pretty messed up. I have authentication. I have a different service for database, different service for client, for backend. It's a mess. right? Especially when thousands of people are using it. For something which I made right now is very easy to handle by a single person like me. But when a lot of people are using it, it's a mess. Kubernetes comes in, it's the coach, and it tells everyone to be organized. It manages all that organization. Uh, So all of these services are connected via application programming interface or APIs. So basically, they talk to each other uh, and act as if all of them are a single service. You don't feel that Instagram has a separate database and a client. All of it just feels like a single product because they communicated with it so well, and Kubernetes makes sure that that flow is there consistently. Imagine, let's say the client side here uh, has a lot of traffic. It's holiday season. A lot of people are using Instagram, and since it's my product, I want to scale it. I want to increase the performance on this side. All right, I'm getting a lot of traffic, so before my application crashes, I have already told Kubernetes that if you see a traffic somewhere, can you please manage it for me? I'm sleeping at home, and Kubernetes, once it detects a higher traffic, will automatically take down the nodes which are failed and generate new ones, even extra ones if it needs to. Uh, Hi Sajaya, hi Somu. How is it going? We are discussing about Kubernetes. If you are new here, that's fine. This whole stream is recorded. We also have the resources on the GitHub for the stream. I think it's also mentioned in the description of the stream. So Kubernetes is doing all of that for me. I don't have to worry anymore that if people are using my product more, I need more machines. And if people are using my product less, I need less machines. Kubernetes will handle that for me. All I have to tell is configure the Kubernetes that, okay, have a certain set of rules and then it will work like anything. Basically, a recipe. Kind of like how we made Dockerfile. Similarly goes for Kubernetes, but it's a bit different. Another advantage of Kubernetes is that's a really nice question. What's the main difference between Kubernetes and Docker? Well, both are different. Both are not same. Kubernetes is an orchestration tool. It's the, I don't know what you call it. The orchestrator you see in shows, the one who commands everyone. It's the coach of the football. Whereas all the players are containers, and those containers were made via Docker. If I go back to the slide, all these players are containers which we made via Docker. We just made one of them. We'll be making multiple. How do we tell to make multiple? How do I tell all of them to automatically come to arrangement? I don't want to be online all the time. I want to automate that task. That is where the coach comes in on the left. That is Kubernetes. Kubernetes tells what is like all of them to just come into orchestration or follow a certain set of rules. So Kubernetes is an orchestration tool, whereas Docker is a containerization tool. So we need Docker to run Kubernetes, but not for long. Kubernetes is starting to work on its own containerization, but for now, we are going to rely on Docker to containerize our apps so it works on all of your systems. So next time when I run Kubernetes, it does not have to worry that whether it's working on a Windows system or iOS or a Mac. It just runs because all of them are containers and containers work everywhere. And Kubernetes is handling all the container actions for me. Should I start a new container? Should I bring down containers? Should I increase the number of containers and stuff like that? Right now, we were running just one container with this example. This is just one container. But one container is not enough for hundreds of people to use that same project. So, that said, there's one more advantage of using Kubernetes. You can use it on multiple clouds. All cloud platforms have Kubernetes in it. Since Kubernetes is open source, in fact, most of the popular tools out there uses Kubernetes. So if I go to Kubernetes, oops, I go here. Let me go to case studies. These are all the case studies that people actually, the companies that actually use. Booking.com uses Kubernetes. Adidas, Capital One, IBM, Google uses Kubernetes. All of these, Spotify uses Kubernetes to manage, you know. So, okay, this is a very nice feature. Let's go to documentation, or not documentation actually. Let's go with the advantage of Kubernetes. I can plan it scale. Yes, it can automatically scale. It can never outgrow. If I go down here, look at the features. Some of them you might have observed, but you never really thought it's happening in the background. Automated rollback and rollouts. Did you ever observed when the Reels feature came in Instagram, or when the payments feature came in your WhatsApp if you're from APAC region, or any of those features which just came silently in your phone? You don't have to update your phone, it just came. And sometimes it came in your phone but not in your friend's phone, and it comes after a couple of weeks. That is what it is called our automatic rollout. uh, Kubernetes can do that. It can slowly update rollout updates to all the containers without taking them down. There used to be a time a couple of years ago where you had to install the whole application from the app store in order to update it. So if I was playing a game which is like, a couple of GBs big, when the update comes, it installs the whole game again. That was so annoying. And now, if there's an update, it only downloads that update. In fact, social media that you are using, it silently updates without hindering other functionalities. If I go back to this slide, if I want to update one microservice, I can only take this down. Other services are still working. That's why you're able to use WhatsApp for its communication. When the video call feature came silently without any updates, the chat feature did not go down. Kubernetes can automate that for me. That is one great feature that we observe every day. Self healing is a great property. Sometimes there are blackouts. You see tweets that Stack Overflow is down in all over the world. Sometimes it's down on the North America. But if it's down on North America, it's still working in India and other places. Kubernetes can make sure that if a container is down, uh, a set of containers called a pod is down somewhere, it will automatically start a new one. For example, so right now my container is down and I started it manually. I can stop it manually. Yes. What if it fails to start? Maybe I had some error in the code, or maybe I just don't have the resources. Like my system just crashed 5 minutes ago. I have to manually click here to start it. Kubernetes can do it automatically for me. All I have to tell is, hey, listen, I want couple of this number of sets of containers to run, and if it is down, can you start it for me? And it will do that for me. That's why Kubernetes has like very low downtime. That's why you see uh, websites which are not using tools like Kubernetes or any container orchestration. Once they go down, someone has to manually pull it up. Yep, K8 is Google's baby. Google open sourced it. That is correct. It's a Google's gift to everyone. I like this feature called horizontal scaling. It's horizontal scaling means adding more machines. So if you're using a cloud computer, if you're using Google GCP or anything that is here, you're basically using someone else's computer. Simple as that. And if more people are using your website, more people are using your product, there's going to be more traffic, and you need more computers for that. So instead of manually increasing the number of computers going to AWS and asking for more, you can just tell Kubernetes that hey, if you detect more traffic, increase the number of computers used, also known as horizontal scaling. This will make sure that my system does not go down even if there is more stream. At the same time, let's say people stop using it after some time. If I don't reduce the number of computers that I have bought from these cloud providers, it's going to cost me a lot, because uh, cloud can be expensive if you increase the number of computers. So instead of manually detecting that, I again tell Kubernetes that, hey, if you detect that there's less traffic, just decrease the number of computers being used by the cloud. This will save me a lot of cost. So that is one example of horizontal scaling, which we don't see it, but it is right there. So Kubernetes, there's some brief idea of what Kubernetes is used for. It's used everywhere. Uh, and Yeah, we are going to, so we have containerized our app. We have, if you are new here, if you just joined, we have containerized our own application and it is right there. So we containerized our simple Node.js file, which runs our index.html, which says hello world, hello global hack week. And that's what we have done today. Now I want this container to run on Kubernetes. That is what we are going to run do tomorrow. So tomorrow we are going to learn a bit more what it takes to actually run stuff on Kubernetes, because there is going to be a couple of more uh, theory, like what is load balancing. Installing Kubernetes, you can do that if you want to save time. You can play with it, and how to use kube control or kubectl commands and stuff like that. And after that, we are actually going to experiment with Kubernetes. We are going to do everything that is mentioned on this website. So we are going to try to horizontal scale it. We're going to destroy the pods and see it self heal on its own. And let's see, if we had time, we could also try automatic rollback and rollouts. But that's it for today. That's a lot for today. If you want some homework, or if you're curious and if you're not satisfied with today's stuff, see if you can containerize your own personal project. I would love to see your projects on Docker Hub. I would love to try it out. Share it in the Discord channel. Explore other images on Docker Hub. So if you are on Docker Hub, just click here. It is explore button. uh, lots, and you can use Python too. Yes, I forgot to that's a great example. So I can do Docker run Python, and without installing Python, I can write it on my system. So if I do Docker run interactive environment Python, I don't have Python locally, so it's going to go to the Docker hub and pull the Python for me. I'm new to CNCF Kubernetes Canadian infrastructure. Yes, you can apply for scholarships when they come. Highly recommended. Uh, I would highly also recommend checking out CNCF's old talks. There are lots of talks on Kubernetes and KubeCon. There are some great talks you can check out. You don't have to wait for the next KubeCon. You like the way I explained with the football player? Thank you so much. It really is simple as that. It really works like that. Kubernetes is the coach, and it just tells what to do, and they just follow it along. I use the term CNCF. CNCF stands for Cloud Native Computing Foundation. Uh, so what we're dealing here is with cloud technology, right? So this is an open source computing foundation. When Google open sourced Kubernetes, it donated this project to the CNCF, where CNCF made sure it is funded. This project is funded, and it becomes mature with time. So people can work on it since it's open source. Um, it has to, in order to survive, it has to be sponsored regularly. So CNCF has a lot of projects which are open source and used by a lot of industries out there. In fact, 90% of the code out there that we use is has somehow a open source tool in there. And CNCF makes sure that all the projects are being funded and stuff like so. So if I go here, you can see projects which are being incubating. That means these are the projects which are under progress, which are being furnished, uh, so they can be graduated once they are like prepared for like proper world use, and they can be their own product on its own. So Kubernetes, you can see, is already graduated, and there are a lot of incubating projects on CNCF. So if I go here, there are tons of landscape here. So if I go to landscape, look at the amount of projects that CNCF has. Oh, wait, there's something wrong. Oh, I have a filter on. Wow, that's a lot of projects. Kubernetes is somewhere right here if you can spot it. There you go. That's, oops, I'm gonna hide myself. That small thing right here is Kubernetes. There are so many projects to explore. All of them are helping one another. Just like Kubernetes is helping in container orchestration, we have other projects which help in a lot of stuff. We have serverless and so much to explore. I'm not going to get into that, but CNCF is an organization which makes it possible. Uh, that said, that's it for day one. If you have any questions, feel free to ask it. I would love to see if you have any doubts. Ask. We can ask them in the Discord chat. We can also follow those doubts tomorrow. Everything, once again, everything is there in the GitHub repository. If you don't have it, let me just copy this. Awesome. I'm glad you learned a lot. Okay, what time date will start? Exactly the same time which that was today, 7 a.m. ET or 5:30 p.m. So if I go to schedule here, they're right there. That's it. Part two. If you want, you can add it to your calendars. Let me just share the check-in link for day two. Make sure you have checked in for day one. All right. You can check in here and add it to your calendar so you don't miss. Let me also highlight. Oops, not this one. So make sure if you want to catch up with all the resources, these are the resources, everything that you need to install, including the slides that I showed you. The slides are at the bottom, workshop slides are right here. There's some extra resources to help you start Kubernetes, and everything else should be here, and I'll just keep updating it as we go along. Awesome. Looks good so far. Awesome. I'm glad you liked it. That is great. Will you use Minikube? I can. I can use kind. If you don't know what is Minikube, it is a tool which helps us learn Kubernetes locally. There are multiple tools. So if I show you Kubernetes or kubectl, so these are tools that I can use. There's kind, there's Minikube, there's kubeadm. All of that, as again mentioned in, I guess, here. No, okay, fine. I'm gonna mention that too. I'm gonna add that. But you can use these tools. If you have Docker Desktop installed, there is option to use Kubernetes inbuilt in that. So I go to settings and there is Kubernetes inbuilt. So that saves me a lot of time. But I prefer using kind. You can use whatever you like. The concept should be the same. There is no Docker extension as far as I know, but the link to install, you can just Google it, Docker Desktop to install Docker. Awesome. I'm gonna close this. That was nice. I might containerize some more applications so far. Do we have any more questions? If not, I think that's a lot for today. For one day, I think that's a lot. We learned a bit of backend. It's all right if you don't know, you can use your own project. Just make sure it is being served by some server, Node, Nginx, anything works. It is somewhere being served. We learn how to containerize, we learn how to push our container into the application, we learn how to pull it and run it interactively. Lots of Docker commands. I'm going to list that out also. And it was fun that now I can share a lot of stuff using Docker. So today was entirely Docker, and tomorrow we are going to put a little bit hands on Kubernetes. So if you want to save time, have kubectl installed, but it's all right if you don't. I'm going to show you how to enable Kubernetes live here too. Awesome. Sounds good. I'm going to put your favorite music back up. And thank you so much for joining us, folks. We will see you on part two tomorrow at same time, 5:30 p.m. IST or 7 a.m. ET. And we're going to continue, folks. All right. Have a great day. Bye.